Today we're going to talk about hash tables, which are the most important data structure you need to ace coding interviews. I'll be going over them quickly, so you should pause this video often or play it at a slower speed until you understand all the steps in these slides. Once you understand them, you can use this video as a quick reference to brush up on hash tables before an interview. Hash tables, which are also called hash maps or dictionaries, are important because of their speed. You'll often see them used to turn a slow, brute force solution into a blazing fast optimal algorithm. A hash table is a collection of keys and values. Here we have a hash table with countries as keys and capitals as values. Keys and values can be of any type. This hash table has strings as keys and strings as values. This one has strings as keys and integers as values. To use a hash table, you first insert all the key-value pairs, then you can give the hash table a key to look up its associated value. Here's how you do that in Python. A hash table works by storing all these values in an array. It does this with a hash function which takes in keys and outputs integers. Then an index is generated by modding the hash with the size of the array. The value is then stored at this index in the array. This is done for every value. Let's go through an example. Here we have a hash table with names as keys and phone numbers as values. Let's say the array that stores values in this table has size 16. To insert John's number, we first compute the hash of the key. Let's say it's 18. The size of the array is 16, so we have to mod 18 by 16 to get our index. So we store John's number at index 2 in the array. To add Lisa's phone number, we hash her name, compute the index, and store her phone number at position 1 in the array. To store Sandra's phone number, we hash her name, compute the index, and store her value at that index. Now someone wants to look up Lisa's number, so they give us her name as a key. To do a lookup, we go through the same steps, we hash the key, compute the index, and finally return the value stored at that location. Here's a visualization of how the hash table looks like at the end of the code. Hash tables are fast because the hash function runs in constant time, meaning that the time it takes to hash a key does not depend on how many keys we've already stored in the hash table. Let's use that information to analyze the complexity of insertions. The hash function runs in O of 1 time. Computing the index requires 1 computation, so it also runs in O of 1 time. Array indexing is a constant time operation, so the total time needed to insert a value is the sum of these times, and it is also therefore O of 1. Same thing with lookups. Hashing is O of 1, computing the index is O of 1, array lookups are O of 1, so lookups are completed in constant time. But it doesn't always go so smoothly. What happens when two elements hash the same value? This is called a collision. Let's look at what happens when these two keys collide. Let's say John's value is inserted at position 152. Sandra's key collides with John's, so we store her value at the same index. Notice that this overwrites John's value. Now when John's name is looked up, the lookup algorithm will hash it and return the value stored at that index, which will actually give us Sandra's value, not John's. Collisions can happen even if two keys have different hashes, by the way. Here, Mike's value collides with John's even though they have different hashes because the indices are still the same. One way to handle this is to use separate chaining, which means to store a chain or list at each index in the array. Each value inserted is now added to the list of keys and values at that index. So when John's key is looked up, for example, we still hash his key to get an index, but this time we search through the list at that index until we find a key value pair with his key. Then we return the associated value. This is how a separately chained hash table looks. Compare it with the visualization we saw previously to understand the difference. Collisions increase the time complexity of lookups because if many keys collide, searching through the list might take O of n time. In practice though, and definitely in coding interviews, you can assume O of 1 runtime. This is because modern hash tables will resize the array so that the longest chain always has constant length. Note that you need O of n space complexity to store all the keys and values. And that's all you need to know about hash tables.